Let's shoot so. I found it. Next thing that I would like to do is what you call power series. You want to take a break?
No, sir.
No, you are used to that.
Yes.
Well, obviously, saying why you want to go away.
If they want, sir.
No, sir. Okay, what's a power series? We define what you say, but power series. Imagine I have a sequence of complex numbers. It should be real as well. Then this kind of series here is that power energy. Where complex number that's called so you have a sequence of complex numbers. You are multiplying that sequence of complex number with the terms. So in other words, if I write it more explicitly, so I take C1 multiplied C0 multiplied with Z raised to 0. I have C1 Z1 power 1 plus
C1 Z, C2 Z square.
square and so on and so forth. So this kind of thing is going to be a power series. So if these C0 and C2s can be real numbers and can be complex numbers. And similarly, Z is a fixed number as well. And you're taking a sequence and multiplying with and defining power series. Okay? And then I would like to talk about the convergence of such kind of power series. Why such power series are important? Have you seen any use of such kind of power series yet? I mean, if you see, when you have a Taylor expansion, you have actually a power series.
जी सर
You have a Taylor expansion of something. It's nothing, just a power series.
जनरेटर भी इसमें
And
सर
if we see what is Z there, obviously you have Z, but like the role of Z is played by this fixed number x minus say x naught, where x naught is the fixed number out which you are computing
Power.
and power and what you have in coefficient value.
Derivatives.
डिवाइड बाय
Which you say that nth derivative
डिवाइड बाय
Yes.
and computed at x naught
डिवाइड बाय
divided by n factorial. So that is like your Cn.
CL.
जी सर
That is like your Z. We have already encountered some kind of power series. Okay? But you never asked a question that why such a series converge out. Okay? Now we are going to basically do a little test. One liner proof of it. Just video one liner of the test for the convergence of power series. Okay. you see that, let's say, imagine I have been given a power series, 3n z raised to n. And so put alpha as length goes to infinity of nth root of the magnitudes of Cn's. Right. And so R the number to be 1 over alpha. So R is representing the reciprocal of this length root. So what we can say, just think about it. If alpha is 0, the R is going to be plus infinity. If alpha is plus infinity, R is going to be. In other words, that if this is finite, the R is going to explode. If alpha is infinite, then R is going to. That's then this series is Cn that is to n converges. Okay. If the magnitude of Z is smaller than R. Converges if magnitude of Z is bigger than, and if the series is converging, you call R as the radius of convergence. Radius of convergence. So you have been given a series, you will say that okay, check that whether this converges or not. If it converges, what is the radius of convergence? So roughly what we are saying that imagine I have a series given which will be real and complex both restriction, and we take the length root of nth root of the coefficients and you choose them to be alpha. And you say that okay, the series is going to converge if the magnitude of these z's is smaller than the reciprocal of alpha. It is going to diverge if magnitude is bigger than the. So you can already see that this radius of convergence is nothing, it's just the length root, the nth root of the length root of the series, the coefficients. My claim is this, that I can directly follow it from, there is no need to do any new thing, I can directly follow it from my nth root test. If I would like to follow it from my nth root test, what should be my choice? What was nth root test? I mean, if you just flip your pages, it says that the series A n converges if the length root of
nth root of n
the absolute of n is
less
less than 1 actually. So what should I choose an? If I would like to apply that previous case, what should I choose to be there?
Cn z.
So it should be Cn raised to the square. Okay?
Yes.
And then if I take limits of n goes to infinity, okay, of nth root of a n, obviously is going to be magnitude we're going to have. my claim is that this is going to be equal to the magnitude of Z. Can you see why?
Alpha into Z. Alpha into Z.
Okay. Why alpha into Z?
क्योंकि सर वो सीक्वेंस में आ जाएगी सी एन सीक्वेंस रहेगी ना वहाँ
Saying that I have a glimpse of of what? Cn z raised to n, which magnitude? Okay. And then I know that the product of magnitude of two complex numbers is same as the product of magnitudes of the difference. So it is going to be the nth root of Cn times the nth root of magnitude of z raised to n, which is going to be same as magnitude of z. But we have given this body a name
Alpha.
that body is alpha. Ready? So what you get is alpha. Ready? So if it is alpha magnitude of z, what does it follow? That means that this is going to be same as magnitude of z divided by r. Okay? So I know that if this guy
And if it's less than
and if this guy is smaller than 1, then the series formed by an is going to converge at
converge.
and the series formed by an is basically 1 or series. So you want this to be less than 1,
Which means you want Z to be less than R.
which means that you want magnitude of z less than r. In other words, we know that if this lim suit is smaller than 1, then the series is going to converge. But if this lim suit is smaller than 1, so this is equal to this guy finally, so this must be smaller than 1. So if this is smaller than 1, the magnitude of z is less than r. In other words, we are going to say that this series, which is sum an, which is same as sum cn zn, is going to converge if the magnitude of z is smaller than r, and if this guy is bigger than 1, then the series is going to diverge. Series formed by an is going to diverge, which is going to imply that magnitude of z is bigger than r. The result is applied that simply doing test. Is it making sense? Okay. Try to make sense of this, make habit of this, basically applying the result. Yes. I may have not written all details here. I'm just giving you a verbal description. You have to basically, at least once in your life, you have to write this proof correctly in its full detail. Okay? With all that reasoning. Try to get it up. Then you can't say about this series may converge, may diverge.
Then it's simply CN.
Series. So you have a series for which you can't say partiality. Please take this. Let's do some examples. Let's do some examples. So one remark is this before we take an example. So if x equal to infinity Cn z raised to n, this R is called the radius of convergence. It's called radii. So, let's take it. So, if your z's are sitting between, within this radius, your series is going to converge. It's going to be already an important information. So, in other words, the nature of convergence of such a series depends on basically this R, which is just simply inverse of limb suit. So we can already see that how much limb suits are important. They are already quite important, guys. If this reciprocal of this limb suit, so if your magnitude of Z is sitting between reciprocal of this limb suit, you are safe, the series is convergent. If you are going beyond, so let's give an example. N raised to n and z n. What will be the radius of convergence with this size? First of all, you need to take Cn, which is n power n raised to n. Okay. And what would be the absolute of this is going to be say. Okay. And what would be the limb suit of this actually?
N to plus.
The limb suit of this.
So won't we be taking the nth root?
Huh?
Nth root is the name.
Well, so let's take the nth root of this, which is going to be L. So what is the limb suit of n? In other words, I'm saying that what is the limb suit? And goes to infinity for this sequence n, which is plus infinity. Which is plus infinity. So if this is the case,
R is 0.
then your R should be what?
0.
It should be 0. Okay. So can you have a complex number whose magnitude is smaller than 0?
Itself you
0.
real counting.
It is the strictness there. There is no such complex number.
Equal will be less.
So the word is diverges. How about if I have z raised to n over n factorial, which is equal to what? E to the z. Should converge. Expansion of e to the z, roughly. Anyway, forget about that. So what will be the Cn here? 1 over
Factorial.
n factorial, take that. N to get part. N to root of this guy. So what do you think that what should be the limit suit of this? What would be the limit suit? My claim is the limit suit for such kind of this expression is 0. Why? I mean, one of the things is that it converges to 0. Because sometimes you want to find limit or lim suit. Okay. You can also find limit of the sequence, and you can say that okay, if the limit is converging, then obviously the lim suit is going to be equal to the limit. So this is clearly a convergent series. I will move to the lim suit. So this is convergent, then the lim suit is going to be what the limit of the hence which is 0. So if this is the case, then R must be
Plus.
We are going to say that this series z raised to n over n factorial converges for all those complex numbers for which the magnitude is finite. And all complex numbers have magnitude finite. You can't have that. So in other words, this converges always. How about consider this terms Zn, this series. So what will be the Cn for this series? So if you take the absolute,
So
and you take the absolute,
R is 1.
which converges. In other words, you're going to say that
Alpha is
R is 1.
no, the mod of Z should be less than 1.
Not
You're going to say that this is going to converge if your
norm of Z is
Norm of Z.
just like this is going to converge if and only if your absolute of magnitude is smaller than 1. Take any complex number whose magnitude is smaller than 1 is going to converge.
the same as genetics.
So it's not really a geometric series because
With
that is not a complex number. Right? You don't have that is not available. Is it making sense? Still, you can talk about. So basically, when we are having power series, we are kind of extending our notion of series, which was previously only for real numbers, to the series of complex numbers. Now you can also talk about the complex series is that. But not all kind of complex series which are of this form. ठीक है जी. So I have uploaded basically some chapter in which there are very easy, small, simple exercises related to all these actually. So you have to just do exercise. Don't follow the text from there because that text is elementary. The text, the proofs that you have to follow, you have to follow from here. It's few just exercises there. Basically, practice on. Alright, so for power series, we're just going to do this result. Okay. And let's for the next part, which is very interesting. Involved summation analysis. Summation by pass. Is it giving you into that what you are going through? Oh, yes. Have you seen something like this before? have integration by parts. Analog of integration by parts. Have what we call the summation by parts. We know that integrals are basically sum. So if you have integration by parts for integrals, you should have summation by parts for some sum. Let's try to make sense of it. So let's try to prove the result something based on the summation by parts. Imagine I have been given two series. I have been given series A and B and put this big N as the sum, partial sum from 0 to n. And for convenience, I'm going to maybe I will need basically this A minus 1. If I need A minus 1 now, I'll just define A minus 1 to be A2, okay? Then for P bigger than or equal to 0 and Q, we have this quantity. So there you have integral which starts from sum A to B actually. So you have a definite integral with finite limits to be infinite. True for infinite limits. You should have something like that. So imagine I have a sum. P and Q are two numbers, natural numbers. So n which begins from P to Q. I have product of these two series, A and B n. Okay? It's equal to what? Because it's a boring formula, and it's a very switch formula for you. It's sensitive. So which is
Very beneficial. I use some integral of
Very beneficial.
very
Beneficial.
beneficial law, but they justify some.
How big is that?
Use very weird. Okay, so this sum, which begins from P and Q, is equal to a sum equal to A, B, to Q, same as capital A N times B N. N times N minus Bn plus 1. Okay. Plus Q minus Q. So it's like Q's minus P minus 1 B to P minus all those values just 100 missing that. Very weird looking formula. So let's try to see. So what is the analog formula? Integration by parts. So you have A to B. You have U dV. So going to be equal to what? You have UV on A to B minus V and E.